Now in this video we are going to discuss test for cations. So what are cations? These are positively charged ions. अब cations के लिए we are using two types of solution. One is sodium hydroxide and the other is aqueous ammonia. Some people call it ammonium hydroxide. This one is called sodium hydroxide. And you can see both solutions are basic in nature. Now one by one we are going to discuss the test. First is aluminium. When sodium hydroxide few drops are added, what will be formed? White precipitate. When excess sodium hydroxide is added, what about this precipitate? They will get dissolved and will giving a clear solution. When for aluminium, aqueous ammonia is being added, what is formed? White precipitate, and those are insoluble in excess. The second cation in your syllabus is ammonium ion, NH4 plus. So when sodium hydroxide is added and you are going to heat for some time, ammonia gas will be formed. And what is the conformation? Pungent smell. That is the smell of ammonia. And definitely there will be no test because this is also ammonium ion and we are adding ammonia solution that already contain ammonium ions. So when ammonia solution is added to ammonium ions, there will be no reaction. So I have shown you dots. Third one is calcium ion. When few drops of sodium hydroxide are added, what will be formed? White precipitate. When that sodium hydroxide is added in excess, that will remain insoluble in excess. And if ammonia is added in calcium ion, what can be formed? No precipitate, or you can say very light white precipitate. For chromium ion, when sodium hydroxide few drops are added, you will see green precipitate. When the same sodium hydroxide that is added in excess, those green precipitate will dissolve. When ammonia solution is added to the chromium ion, what you will see? Green precipitate. And if the excess amount of ammonia is being added, those precipitate will remain insoluble, mean no change. Now for copper, Cu2 plus, when few drops of sodium hydroxide are added, you will see light blue precipitate. When sodium hydroxide is added in excess, what you will see? Those blue precipitate will remain insoluble, mean no further change. When ammonia solution is added to the copper ions, light blue precipitate will be formed. And if further ammonia is added, excess amount is added, those will get dissolved and you will see a dark blue solution. For iron 2 plus, when sodium hydroxide few drops are being added, green precipitate. Now there is a confusion. For Fe2 plus and for chromium 3 plus, the color of the precipitate is same. Then how we can differentiate? When further sodium hydroxide is added, these precipitate will remain insoluble if it contains Fe2 plus, and if it contains chromium, these precipitate will dissolve. And for Fe2 plus, if that solution is kept open for some time, the color was green, that will turn brown. What is the reason? This Fe2 plus will oxidize as there is oxygen in the air, and Fe2 plus will change into Fe3 plus. So any salt containing Fe2 plus, those are placed in the closed container in the lab. If those chemicals, those salts which are containing Fe2 plus, if they are kept open, they will oxidize, they will react with the oxygen present in the atmosphere, and these ions Fe2 plus will change into Fe3 plus. Okay. For Fe2 plus, when ammonia solution is added, green precipitate, insoluble in X's, turn browns on the surface, and I have explained it earlier. Now Fe3 plus, if a salt containing Fe3 plus and you are adding few drops of sodium hydroxide, reddish brown precipitate will be formed and those will remain insoluble in excess. If ammonia solution is added and Fe3 plus, reddish brown precipitate, insoluble in excess. So for Fe3 plus, the test with sodium hydroxide solution and the test with ammonia solution, that is same. The last is zinc, Zn2 plus. If any salt containing zinc ion and you are adding few drops of sodium hydroxide, white precipitate will be formed. If you are adding excess sodium hydroxide, those white precipitate will dissolve and giving a clear solution, colorless solution. Okay. If ammonia solution is being added, a salt containing zinc cation, white precipitate will be formed, soluble in excess, giving a clear solution. Now there is a confusion for zinc cation and aluminium cation. The results for sodium hydroxide, for aluminium cation and zinc cation is same, but when ammonia solution is added, they show different result. For aluminium, white precipitate, insoluble in excess. For zinc cation, white precipitate but soluble in excess and giving a colorless clear solution. So this was all about the test of cations in your syllabus. I mean, in this video we are going to discuss the test for anions. You know, anions are negatively charged ions. Okay? Now the common anions in your syllabus, first is carbonate. So we have discussed the reactions of carbonate with acids. So if you are adding hydrochloric acid and the salt containing carbonate ion, definitely carbonate salt react with acid and they will form carbon dioxide. Then you will confirm that the gas is carbon dioxide. If carbon dioxide is passed through a lime water, that turns milky. So what will be the result? If for within you can write bubbles, and those bubbles are the carbon dioxide gas. Second is chloride. Now keep in mind, there are three halide ions. There are three halide ions: chloride, bromide, and iodide. The chemicals added are same for those three. We will add first nitric acid and then aqueous silver nitrate. And you will see different types of precipitate. Now the first question is this: why we are adding nitric acid? The reason, listen the reason carefully. When we are testing halide ions, first we will add nitric acid. The reason is what? If the solution contain any carbonate ions, the solution also contain any halide ions, and there are also some ions of carbonate. Those carbonate ions will react with nitric acid, and you know, when carbonate react with acid, carbon dioxide gas will be formed and those ions will be displaced from the solution. That's why first we will add nitric acid. And if we don't add nitric acid and we directly add silver nitrate for these halide ions, and if these halide ions also contain carbonate, then silver nitrate will react with carbonate and silver carbonate will be formed, that is also a precipitate. So to remove any traces of carbonate ions present in the halide ions, first we will add nitric acid. Then we will add silver nitrate solution. For chloride ion, you will see white precipitate. For bromide ion, you will see cream precipitate. For iodide ion, you will see yellow precipitate. For nitrate ions, first we will add sodium hydroxide solution, then we will add aluminium foil, and then we will heat, slow heating. What will be the result? Pungent smell, mean ammonia gas will be formed. This is a basic gas and we can confirm it through by litmus paper. The other is sulfate anion. First we will add nitric acid solution, then we will add aqueous barium nitrate solution. White precipitate will be formed. For sulfate it is -2. For sulfite it is also -2, but for sulfate it is SO4. For sulfite it is SO3 2 minus, just a minor difference, okay. First, so we will add small amount of acidified potassium magnate. This is an oxidizing agent and the original color of potassium magnate solution is purple color. If sulfite ion is present, the color will change from purple to colorless solution. Now just keep in mind, for anions we are using different solution. For halide ions, that may be chloride, bromide or iodide, the solution is nitric acid and then aqueous silver nitrate. For carbonate, for nitrate, for sulfate and for sulfide, the solutions are different. So this video was about the test for cations and test for anions.